So good day everyone. Welcome back for another video. This is ECE 23, Module 6 Performance Task Introduction to Digital Communications. This is Mr. S. Arcabal, DSECE 3C. Today we're going to discuss convolutional codes. Convolutional code is a type of error correcting code that generates parity symbols via the sliding application of a Boolean polynomial function to a data stream. So in short, convolutional codes is a type of error correcting code. So we have here a diagram of convolutional coder rate 1 over 3. Determine the following: transition table, state machine diagram, and tree-less diagram. So out of this diagram, we will determine the following. So the transition table. Transition table is basically a tabular representation of the transition function. It takes two arguments, a state and a symbol, and returns a state, the next state. A transition table is represented by the following things. Columns correspond to input symbols. So, in short, transition table is used to determine next state, or our next state given our current state and our input generated to the system. So, for getting the next state, we have input of 0. So we have an input of 0. Let's assume our S0 is equals to 0 and our S1 is equals to 0. To determine the output N1, so we have here the following formula. Input XOR S0 XOR S1. So we have input of 0 XOR 0 XOR 1. So 0 XOR 0 XOR 0 is equals to 0. So for getting the value of our N2, we have this formula S0 S0 XOR S1. So 0 XOR 0 is equals to 0. So our entry formula, we have here input XOR S1. So we have 0 input XOR S1. So 0 XOR 0 is equals to 0. So next state. To determine the next state, this is a shift register. So it is shifted to the right. It means our bit is shifted to the right with 1 bit. So we have here um, input of 0. Let's assume as S0 equals to 0, our S1 is equals to 0. So our signal will be shifted to the right. So our value of S1 will go here, 0. The value of S0 will go throughout our S1 and our input will go through in of our S1 S0. So next state from our next state from 0 to 0, current state of 0 to 0 will equals to be 0 0. So next we have an input of 1. Let's assume our current state S0 equals to 0, our S1 is equals to 0. For getting the value of N1, we have here this formula, input XOR S0 XOR S1. So we have here input of 1 XOR 0 XOR 0. So we have the value of 1. So next, for the value of N2, we have this formula, S0 XOR X1. So 0 XOR 0 is equals to 0. Our value of output of N3, we have this formula, input XOR S1. So we have 1 XOR 0. we have the value of 1. So for next state, we have this from next state. So we have here from current state, we have 0, S1 of 0, and we have an input 1. So our next state is shift right. So our state is at shift right. So this bit will shift to the right, and this bit will shift to the right. So, and this input one will shifted to the right. So our next state will be 1 and 0. So this process goes throughout until the last of our input 1, current state of 1 1. So this process is repeated until our last input. So next, a state diagram. Sometimes known as a state machine diagram is a type of behavioral diagram in the Unified Modeling Language or UML that shows transition between various objects. So we have here our transition table, and we have here our state diagram. We have four state diagrams: 0 0, 0 1, 1 1, and 1 0. So from current state 0 0, we have next state from 0 to 0. So we have an input of 0 and an output of 0 0 0. Next, we have input current state of 0. Next state from 0 0 to 1 0. We have an input of 1 and an output of 1 0 1. So next, we have input of current state of 0 1 going to the next state 0 0, and we have this input of 0 and output of 1 1 1. So this process is repeated until the last input. So next, from one input of 1 0, input of 1 0, going to next state 0 1, we have an input of 0 and an output of 1 1 0, 1 1 0. Next, from 1 0, next state of 1 1, we have an input of 1 and an output of 0 1 1. So this process is repeated until to the last input. So next, we have the trellis diagram. Trellis diagram is defined simply as a plot of all possible states versus time. So we have current state 0 0, going to next state of 0 0. We have an input of 0 and an output of 0 0 0. Next, we have current state of 0 0, next state 1 0, input of 1 and output of 1 0 1. So next, we have current state 0 1, next state 0 0, and we have an input of 0 and an output of 1 1 1. Next, we have an current state of 0 1, next state 1 0, an input of 1 and an output of 0 1 0. So next, we have input of 1 0, current state of 1 0, next state 0 1, an input of 0 and an output of 1 1 0. Next, we have current state of 1 0. So this process is repeated until our last input. Our last input here is current state of input of 1 1 and next state of 1 1. with an input of 1 and ay, an input output of 1 0 1 0 0. So that's all for this video, and thank you. See you next time for another discussion.